So this is the completed work for the merry-go-round problem. So what's happening is, hang on. So a child is sitting on a fiberglass goose mounted about 6.3 meters from the center of the merry-go-round, and it's rotating once every 10 seconds. So this entire thing takes about 10 seconds. So the problem is asking what the child's speed while it's sitting on the goose is, and then what's the kid's acceleration while sitting on the goose, and then what's the child's acceleration if they move the little ride thing to 5.2 meters from the center instead of 6.3 meters. So in the first one, it's asking what's the speed while he's sitting at 6.3 meters from the center. So if you remember back to basic kinematics, speed is literally distance over time. But in the case, since it's going in a circle, the distance is the circumference of that circle, and the circumference can be found with the formula from 2 pi r, and then time, of course, is time. So it would be 2 pi times the radius, 6.3, divided by 10 seconds, and then that's 3.958 meters per second, or 4 meters per second, with sig figs and all. 4.0, sorry. So now it's asking, so that's part A. Now it's asking what's the child's acceleration while sitting on the goose 6.3 meters from the center is. So if you remember, the basic formula for acceleration is v squared over r, velocity squared over radius. And as we remember from the first problem, the distance, or the formula for speed, or velocity, speed, is 2 pi r over t, because you're looking at the whole distance, not just the displacement. So you just squared that, 2 pi over t squared times the radius, and then that would be 4 pi squared r over t squared, and then that's literally v squared over r, and I just realized I wrote that twice. So you substitute in the speed from the first, from part A, and divide it over the radius, 6.3, and then you get 2.5 meters per second squared. Now part C is asking what is the acceleration of the child with a new radius. Now the radius is 5.2 meters away from the center instead of 6.3. So you're basically just using the same, you're using the same basic idea for part B, only now with a different radius. So AC is, the acceleration is still v squared over r, and then that's still 2 pi over t squared times r, and then that's 4 pi squared over t squared r, and then so it'd be 2 pi times the new radius, so it's 4 pi squared over 10. The time is still the same because it's still once every 10 seconds, but the radius is different, so now you substitute 5.2 instead of 6.3, and then you get 2.052 meters per second. With sig figs, that would be 2.1 meters per second. So yeah.